In this video, we're given a few different situations, and we need to come up with the data collection method used in each situation, and we also have to list any potential bias that might come up in that situation. Before we go over the questions, let's go over why we even collect data in the first place. Normally, we want to figure out information about a population, but the issue is that that population is so big that we can't possibly figure out what the true information is. For example, the first question gives us an example where a newspaper salesman wants to figure out how many people in the community enjoy reading a newspaper. And that would be really, really hard to do. So, to figure that out, he's going to come up with a sample, and then he's going to use that sample to generalize information that represents the entire population, which would be the community. The type of sampling method that the newspaper salesman goes with is systematic sampling, and that's because he picks every 10th person that walks into the local grocery store. Anytime a person that is collecting data picks every nth person, so every well, in this case 10th person, every 15th person, 20th person, every third person, every nth person, that usually represents systematic sampling. Now we have to determine if there's any potential bias here. Now remember, when we collect data, we have to collect data so that it's a perfect, or well, as good as of a representation of the population as we can. Remember, the sample represents the population. If we collect it in any way that might create some, like make it not a good representation anyway or throw it off, then that would be called biased. And it's important to remember that there's plenty of different ways that sampling methods can be biased. There's not necessarily one right answer. There's several that could work. In this situation, it looks like the salesman goes to the grocery store right when it opens, and he grabs the first 20 responses. Now, when it opens, that's usually in the morning. Can everybody get to the grocery store early in the morning? Not necessarily. In the morning, maybe a lot of people are getting ready to go to work. Kids are going to school, so it's a busy time. And the people that are going to the store early, that might be people that are retired, for example. So they might be a little bit older and they have a different opinion about reading newspapers. So that would cause some bias there. In question two, it says that a teacher is taking notes as she watches. And this is usually going to be an observational study because in this situation, a teacher is just kind of sitting back and observing students' behavior. On late start days, maybe kids get to sleep a little bit later. So the idea is that they have more energy, they might be awake more, they might be able to focus a little bit better. They're not, dozing off or daydreaming. So she's just watching everybody's behavior and see what's going on in class. So that's going to be an observational study. Again, the key part is that she's watching and taking notes. Now let's take a look at any potential bias. And as we do that, we have to consider the goal of this study. The teacher is looking into the relationship between a student's ability to focus given a late start day. So that's under the assumption that students are getting an extra hour of sleep. Does that really help their focus? So there's two assumptions that come to mind. One assumption is that just because there's a late start, every student is getting an extra hour of sleep. Well, if you told me that I was going to school 1 hour later, I may be tempted to actually stay up an hour later because I know I could sleep in a little bit. So, yes, I'm starting later, but I'm maybe going to stay up 1 hour later too. So that kind of cancels out and I'm not getting any additional sleep. Another assumption kind of piggies off that fact that students might not actually be getting an extra hour of sleep. So, for example, a student might have a younger brother or sister that needs to get to school at the regular hour. So that that student wakes up his normal time and brings his little brother or sister to school. And again, they're not getting an extra hour of sleep. But the study or the teacher cannot decipher who that is. So she's under the assumption that everybody's getting an extra hour of sleep. Now it's important that I'm giving this biased based on my understanding that I think the teacher wants to study the effect of having an additional hour or so of sleep. So if this teacher is just trying to figure out if simply installing a late start day helps students' ability to focus or not, then maybe that would be okay for data. Maybe she doesn't really care if students actually got an additional hour sleep. She's just trying to figure out, okay, let's say there's a late start today and we start school later. does that actually help students' ability to focus? And the last question with the pharmacist, this one is a controlled experiment because there's a treatment being applied. There's 40 people in the room, half of them get a Tylenol pill, which is the treatment, and then the other half gets a placebo pill. Now on to the bias. In this question, it says that 40 people are experiencing any type of pain. So this could be anything from a minor headache to, you know, maybe, I mean, I don't know, they broke their arm or they have a really bad toothache or a really bad migraine. It doesn't really say. So the Tylenol might completely take care of a very small ache. But if someone has a really bad toothache, I doubt that that Tylenol is going to have much of an effect. So that's potential bias. Otherwise, controlled experiments, as long as they're well thought out, um, they usually don't have as much bias as maybe some other type of data collection methods. And lastly, let's not forget about question four. Remember, a sample should be a good representation of a population. And in selection A, it says randomly select one teacher in a school and then select the first 100 students that they have during the day. Well, it's just the first 100 students of that teacher. All the students that they see after that have no chance of being selected, so that probably wouldn't be a good answer choice. Um, B is randomly selecting one day of the week. Again, first 100 students that enter the cafeteria doesn't give everybody in the school a chance to be selected. C says that they're picking 100 students from a list of all the students in the school. So in this case, that would probably be the best option for collecting data because they have a master copy of all the students in the school and they could randomly pick 100 from that. That would be your best option. D, we could talk about that. Post the school survey to the website. First 100 people that respond would be selected. Well, that's just a matter of chance. Maybe some people don't have access to the school website. Maybe they just choose not to partake. So I think C would probably be the best way of collecting data that would limit bias.